In the mitigation steps of your analysis, you have to add features that reduce runoff. And the primary one of the first one is adding new canopy. It's the cheapest way to get reduction in terms of the volume per cubic meter of water. And you can add new canopy various ways, but by far the best strategy is to digitize points for the centers of your new canopy. You don't have to use both conifers and hardwoods, although you can if you want to be as efficient as possible, because while the conifers are smaller, they accept or absorb, intercept more water than the hardwoods do, the deciduous trees. And so if you have a small place to fit them, they might make more sense. You don't have to worry too much about spacing. The cost is per unit area, and it's per unit area at the end, that is after you've clipped the overlap. So you don't have to really optimize the locations to a great extent. You can put them a little closer together. You don't want to spend a lot of time digitizing though. It's best to digitize these points because that's quick, and then buffer around them. And our approach then is to, once we digitize them and buffer, and make sure you have the buffers that remove the overlapping boundaries so that you dissolve between the buffers. Then you convert them to single part shapes, and then you need to clip out from the existing canopy using the erase function. I shouldn't say clip, I should say really erase. And also erase them from buildings. So here I have both different crown diameters for conifers and hardwoods, the conifers being bigger, but you can just put in all one size if you want. I'm sorry, the deciduous being bigger. So this is a deciduous tree, this is a coniferous tree. And this is not a recommendation. I just put these in to show you the difference. These are actually probably oversubscribed. So I then can clip by buildings, erase by buildings, I should say, erasing to get the deciduous out from buildings, and erasing for the coniferous. Now again, there are multiple ways you can do this. You can do two separate layers, one for coniferous, one for deciduous, and do the erasing and then union them and assign values. You can just do one type to make it easier, in which case you'd probably want to use deciduous, because if you plant them in these medians, they'll overlap more of the roads. Or you can use only coniferous. It's just up to you. You just want to add new canopy. The other thing is you can calculate the area after you've done this erasing from the existing canopy and from the buildings. Now that's not really terribly realistic, but we're using just an average cost, and we're assuming the trees are planted and grow to full size immediately. It's not too bad an assumption, because you might be looking for long-term benefits. The tree is going to be there a few hundred years. And so here we have basically the new canopy erased with the old canopy, and this is just the new canopy. Then I can calculate the area for this new canopy layer, because I have to figure out the cost and save that to a table or save that to a value. And then I need to add the new canopy with the existing canopy to get my my updated canopy layer that then I'll use in my analysis, and I can run this through my analysis. Now those are multiple steps. You could build a model builder model to do those steps. I've done that, and this is what it looks like. So here we have the new stems, and I'm in these new stems. Those are the points that I digitize. So I'm trying to reduce my work that I have to spend, and once I digitize the points and just put them in this model along with my existing buildings and existing tree canopy, it goes through and calculates everything for me. My workflow buffers on those stems. I only have one type, in this case, a deciduous canopy type, and so I'm using the buffer distance of 13 meters there. You can see it, and it shows up. And that's the added canopy, and I'm multi-parting to single part just to be careful. And then with that added canopy output, I'll erase by the buildings features. So you see that the erase features of the buildings, and the existing features, the data features, are the added canopy. Then I erase by the existing tree canopy, and that gets new output feature class. I'm multi-parting to single parting that again. Then I'm calculating the geometry outputs. That's to get the area. And I have the added canopy, and I calculate the summary statistics for that. I'm getting the sum of the area and that gets output to a table. So that's one of the things I need for my calculations is the cost of the added canopy. Well, this gives me the area, and then I can export that to a table, and then I'll pull that table and calculate the cost manually. I could do additional steps to calculate that, but it's simple enough. The tree canopy then are input on this union with the added canopy to get my combo canopy, my new one. Again, the multi-part to single part. I'll do this new selection, the type not, con, or deciduous. So I didn't bother giving them basically the deciduous before, and I'm calculating the field to give it deciduous. So I'm making the type a deciduous. So I'm just basically digitizing the points and not assigning the value because I know they're deciduous here. If I were to have both coniferous and deciduous in my workflow, I might do them in different layers, and I would then do another union after I calculate a field, or I could maybe add the fields in the steps and then do the union. There's lots of ways to modify this, and I'll leave that up to you. So I have this combo canopy, then I'll select by layers. Basically, I'll clear the current selection, and then I'll assign the values for canopy height. So I'll open this here, and you'll see that basically I'd already given it the deciduous type coming in, and I look at this in canopy height item, and if it's already tall, I'll return tall. If it's already short, I'll return short. And for all the ones that are left, the new ones that I've added, I'll return tall. So they were already deciduous. Now I'm going to make them tall. And so now this will be ready to enter into my calculations. So here I just basically give it a list of new points, and it takes care of all the housekeeping, adds the variable I need, erases the buildings in the current canopy, unions it with the current canopy, and generates then a layer. And I'd validate and run it, and then the output looks like this here. So you can see here's my combo canopy in the back there. It's the new canopy that I've added plus the original canopy, and then here's the original canopy on top. So you can see how I go from basically the new stem points to this combo canopy fairly simply and fairly straightforwardly. And then this new combo canopy, I can just add that into my calculation stream for my new analysis, and I'll get the increase in precipitation interception and a reduction in runoff due to that. So just to speed things up and make it easy.